algebra lesson 3-5. Now, we've spent most of our time on lesson 3-5 really going over some of the problems from the warm-up. So taking a look at these, which were similar to the problems from the assignment, just to make sure we've seen them again and some more clarification. We want to play the shuffling game. We want to get all the x's onto one side or the other. Since the right-hand side only has x's and this side has both stuff without x's and stuff with x's, probably makes sense to move all of the x's to the right-hand side. It wouldn't make a difference. It just lessens the amount of work you'll have to do. So now we have 3 equals 7x plus negative 2x is 5x. Divide both sides by 5. And x equals 3/5. If you were using a calculator and you went 3 divided by 5, you would have ended up with 0.6. Over here, a few adjustments. Plus negative, and then we make a decision. You want to move all the a's to one side or the a's to the other? It doesn't matter, just pick one. I like to look at this and say, okay, if I were to move these a's, it would take a positive 2a to move it. It wouldn't be enough to make this positive. But if I wanted to move the negative 5a's over, I'd have to add 5a, which would be great because then I'll have positive a's left over. And I just like dealing with the positives because I'm less likely to make any mistakes with them. So I cancel those out and I now have 12 plus 3a is equal to negative 9. And since I moved all the a's to the left, the stuff without a's, which would be right here, plus negative 12, has to go right. Now left with 3a is equal to negative 21 because negatives plus negatives makes more negatives. We divide both sides by 3, and a negative divided by a positive makes a negative 7. Alright, looking at a few more, a little bit more intense now on this one. I would put some clarification in here and make that a 1x plus negative 2x, a 1x plus negative 1x, and then I would look, before I start playing the shuffling game, I have some like parts. That 1x and that negative 2x will make negative 1x plus 3, and 3 plus negative 1x. Now you may recognize that right here we have, at this point in the problem, really the exact same thing, a negative 1x and a negative 1x, a 3 and a 3. But if you're not sure and you keep going, you're like, I'm going to move all the x's to the left. So you add 1x here, and you add 1x here. Then what happens is they cancel, those cancel, cancel. You're left with 3 equals 3, which is an identity situation. X could be anything and it wouldn't matter. Pick any number and put it in for x. Everywhere you see it, it will work. The 5x plus 24 equals 5x minus 5 in parentheses. 1x there plus negative 5 there. Probably use the distributive property to get rid of the parentheses so I can play the shuffling game. Now 5x plus 24 equals 5x plus negative 25. And as you can tell, they're not the same. They have the same amount of x's on both sides. So if you use some foreshadowing and you say to yourself, boy, if I start moving all of these to one side, it's going to cancel out all the x's. And you're left with 24 equals negative 25, which is an impossible scenario. So this is no solution. There isn't one that exists. So if the variables cancel out and you get a number equals a number, it's identity. If the variables cancel out and you get a number that does not equal another number, it's no solution. And if the variable is still there and it equals a number, it's one solution. So you have one, none, or a ton in terms of your possible solutions. A couple more from the warm-up. This one's a little bit bigger. We can't do much as far as the shuffling game until we've dealt with the distributive property to get rid of the parentheses. So we'll put a plus negative there and a 1, and we'll distribute. Now the nice thing about this denominator of 3, it works well with both of the numbers inside the parentheses. So you can go ahead and you can pretend like this is 6 over 1. So 2 times 6 would be 12 over 3. 12 over 3 is 4c. 2 times the 3 makes 6 over 2 is, 6 over 3 equals 2. Distribute here as well and you end up with 6c plus negative 18. Now you play the shuffling game, decide. Now when I look at this, I see more c's on that side than this side. So if I move these over here, I'll still have more positive c's left over. Requires a negative 4c to cancel out the positive 4c. These cancel out. I now have 2 equals 2c plus negative 18. So from here, I'll just go ahead and rewrite it up there where I have more room. 2 equals 2c plus negative 18. So we add 18 to both sides. And we're left with 20 equals 2c. Divide both sides by 2. And we get a final answer of c equals 10. C equals 10. And one more, an even more complex looking problem. Make sure I got plenty of room here. Now, a lot of signs to be careful of. I cannot caution you enough. I know you don't have to do this, but it sure reduces the number of mistakes that people make with their signs. And here's the most tricky one. Because it's a negative sign on the outside, you're subtracting all of this. What I do to keep track of it is I make this plus the opposite, and that sign actually gets distributed to both. Now someone's going to say, but it's already negative, I don't have to distribute it. Remember, this is also pronounced opposite. So it's the opposite of what you have here, and the opposite of what you have there. We would have 6y, because nothing's happened to it, plus, this now becomes negative 3y, and this becomes positive 6. That is absolutely crucial. That whole step right there of how you deal with those negatives, if you don't deal with them correctly, you'll almost always mess it up. And it will have catastrophic effects to the rest of your problem. You now have some like parts here. Do you have more positives or more negatives? You have 3 more positives, plus 6 equals 5y plus negative 4. We then decide, do I want to move all the y's to the right or the left? The way I decide is I just look at which side I have more. I've got more positives over here than I do over here, so I will add negative 3y to both sides. And I'm left with 6 equals 2y plus negative 4. Now if you're looking at that going, I don't understand why that was how I got a negative there. This was plus negative, so plus negative 3y. Now I'm going to add 4 since I brought the y's to the right. The stuff without y's needs to go left. Those cancel. 10 equals 2y. I'm left with one more step and I've got it solved. Divide by 2, divide by 2, and 5 equals y. So again, we've gone over some of the problems on the warm-up that were similar to the night before. If you have any questions of those, you can always come in and get more help from me. But it's all based on process of a game I like to call shuffling. You want to get all the stuff with x to one side, all the stuff without x's to the other, and then it just leaves you with a one-step problem. Now, we're going to do more of these kind of problems on tonight's assignment, but we're also going to add in some of the possible problem-solving strategies you might use, which would be any diagrams or pictures. So drawing something, especially if it's a word problem, helps you get an idea of what's taking place. You might make tables, like input-output tables, or possibly graphs from those input-output tables, maybe a line graph to decide whether or not a pattern is existing to help you out. So it's still more of what we've been doing, but we might have some story problems. Remember, the story problems are related to these multi-step equations, which means you might be able to solve them in a similar way. Get your bearings about you with some of these drawings and pictures, and then try them out.